Hello everyone, and thank you very much for being here with me in this last video of this playlist where we discuss the remaining of chapter 15, the last chapter in Spring Start Here, first edition. I have very good news for you. A second edition will be announced soon, and this is exactly why I wanted to start this video with this excellent news. What I believe will make you happy. And today what we do is discuss the remaining of chapter 15, which is about integration testing. I want to emphasize more about testing in general because, again, as I have said also in the previous video, it is a subject that is very much underestimated by developers. It should be a much more it should be considered of much more importance. It is of much more importance. The only problem is that a very big part of the developers don't consider it and underestimate it a lot. Okay, so I want to stress on it as much as possible now, and then of course I want to go back and go again through our discussion, through the table of contents and what we've discussed in this playlist. And of course, if you have questions and if you are here with me live, then you know I have also the live chat there, and I keep an eye on the live chat to see if you're writing something. If not, I'm looking forward for questions on social media or in the comment section. And of course, if you are not already a subscriber, subscribe to the channel and tell others about the channel, because other playlists and other live events will follow, and I'm very happy to be here with you and discuss with you wherever you are around the world. With that being said, I want to start by already sharing my screen. And if you were here with me last time, you remember that we were discussing this chapter 15, which was about testing, the last chapter of Spring Start Here, teaching you how to write tests in Spring applications. And again, the classification that I make is in integration tests and unit tests. So we discussed unit tests, and hopefully you understood in our previous discussion that unit tests are about mocking everything that is a dependency of a particular piece of logic and only testing that piece of logic without delegating to any dependency. That is why it's called a unit test, because you only test a particular unit of logic. You test basically the whiles, the ifs, the switch, the try-catch, anything that is decisional or repetitive, creating a particular piece of algorithm representing something. So you know what that something is. It's most likely part of a business logic, no? And you have to make sure through a unit test that that particular piece of logic does exactly what you expect it to do. Integration tests, however, they, as the name suggests, they test the integration between at least two components. And I didn't put too much, unfortunately, here in what integration is and too much advice, but I'm pretty sure this will be one of the changes that I will do for the next edition of the Spring Start Here, which I have just signed for. So it is probably in a couple of months from now on, the moment of recording this video, that you will have access to the early access of the second edition. So I'm looking forward, of course, to your feedback at that time. So integration tests, and here I'm going to explain a little bit more than what you see in this section 15.2 of the first edition of Spring Start Here. What exactly means testing the integration? Whose integration makes sense to test? No, and what kind of integration tests do we have, and how do they actually how do they actually fit in the strategy, in the testing strategy that we apply to our system. No, last time we discussed about this testing strategy, which I said is very often missing in many teams, in many development teams and projects. Some developers or some teams, in my experience as a consultant, didn't even hear about a testing strategy. I asked them sometimes, no, when I'm consulting over a project, why did you write a test this way? Or sometimes in the same system I see different styles of testing, and I'm asking them, why is this test looking like this and that test is looking like that? Or why do you have both this test and this test? Because they are kind of overlapping. And they simply raise their shoulders and say, hey, I don't know, they simply asked us for coverage, or I've seen this somewhere on the internet, or this is how ChatGPT told me to do the thing, or this is how I've seen in another side of the application. So many developers don't even think too much on writing the test. If they are asked for coverage, then they simply do their job, putting there the test for coverage, and that's it. But this is wrong. This is not how we write tests. And I think I have promised you also last time my next playlist will be on testing. So now I'm going to discuss it short enough. No, we only have a short amount of time, a short window here at the end of this playlist to discuss about testing and integration testing, but I want to expand a lot more this subject because it's very important, and I want you, the followers of this channel, to understand and to be proficient and to really be professionals up to the end, and that makes testing part of it. So when we write tests, we have to decide which is our testing strategy. Integration tests and unit tests and the way we write them are part of our testing strategy. But the way we write a test, now integration tests, they are not one kind of test in reality. They are a whole family of tests. You can write integration tests to test the integration among two or several components, and you need to decide which are the integrations that make sense for your system to test. And this is very important. This is one of the most important things, because if you don't decide this correctly, then you might write unnecessary tests. You might write overlapping tests that take your time but they don't bring value. You might write tests that make your architecture rigid for changes and give you more work to change things when you have to like deal with emerging architectures. So that's why it's very important how we write a test. So going back to our subject, what does actually integration test mean? An integration test tests the integration between two or more components. In the very beginning, I have here a diagram now. Sometimes, let's say often actually, beginners think that an integration test is designed to test objects of a particular application. So for example, it tests the integration between the transfer controller and the transfer service. So this is wrong. I mean, not that you can't do that, but it doesn't usually make sense to do that. No, the reason you write integration tests is rarely or never actually testing integration between objects of your own code base. Because when you write the code base, well, in most cases, the delegation is the only thing that happens between two objects. So it doesn't really make sense to test a delegation of a method from one object to the other, because it's a very simple action. What do you actually need to test is most likely how your system, how your application behaves with something that comes from outside your application, or at least outside your code base. And then imagine this is basically a very lean, that simple linear design that we see very often. Controller service repository goes to a database. So here you can imagine before the box representing the transfer controller, you have the client. Of course, we can be more detailed. We remember we've discussed in previous chapters, you have a dispatcher servlet. Now you have the Tomcat, and then somewhere here you imagine is the client. It's someone sending REST calls, which end up in controller, which are delegated to the service, which are delegated to a repository, which works with a database, we presume here. What should we test? Well, there are at least 3 things that you would test in the simplest Spring application here. One is how the request gets into the controller. So you could actually test the contract itself. And this is very wise to test, actually. This is a very wise decision when you have REST endpoints to have a test here which simulates the calls through the dispatcher servlet, and testing this way that the real JSON, usually JSON, it could be plain text, it could be binary, it could be because it's REST, but let's imagine it's a JSON body, as it happens in the 99% of the cases. It checks that request, the headers, the body, the content type, they are exactly what we designed in the contract. So they validate the contract is correctly traduced, correctly understood. And that's one of the tests you can do. The second test is making sure that your application integrates well with frameworks that you use. So in this case, of course, because we are in the Spring Start Here book, it talks about integration with Spring Framework. It's very valuable whenever you get capabilities from the Spring, and that's basically what we do. We've discussed this starting from the first chapter. Why do we use frameworks such as Spring? Why do we use Spring? Is because we want Spring to give us capabilities that we do not then need to rewrite on our own. We get them from the framework, but if we get them from the framework, then we might want to test that the way we implemented them stands the same way during the evolution of our application, and of course the evolution of the framework, meaning when you upgrade the framework, does it still work the same way? That's a very important question you have to ask, and in order to be able to answer it, there is only one way: an integration test. So we design Spring integration tests especially for this purpose. So I already see messages in the chat. So do we need to have good code structure before integration test? Very good question. Very good question, actually. Before an integration test, not necessarily, because, and I will explain it. We have unit tests and integration tests. I'm not sure if I said it last time, but I will say it now. I do not recommend usually going on unit tests, because if you do that with unit tests, then they tend to make your design rigid, and I think that is basically why you are asking me this. Your question is actually, if I'm unit testing my piece of logic, doesn't that mean that every time I change it, I will have to change the unit test? And then if I don't have the code right from the very beginning, does it make sense for me to write tests? Will I not actually work more on rewriting and redesigning the test as well? And what is actually the benefit then that I get out of it anymore in that case? And if that's basically what you are thinking about, you are right. With unit test, it happens a lot. With integration tests, however, they are, depending on how you write them, a little bit more flexible. Remember that I've talked about having here an integration test on the before the controller, not to test the contract. I will go back to it. I will go back to it to prove why this is important and how this actually refers to exactly your question. So if you test from here the integration, what the test will do is we'll send the request to the controller and we'll expect back a response. So what you test is that the request is translated correctly and the response coming back is the one that you have expected. It might also test in some cases that, I don't know, records on the database have been correctly stored or updated, but it doesn't usually test the logic. So it is rarely referring to the logic itself. It doesn't test that a decision happened. It doesn't test that a while loop iterated 10 times. It doesn't test that an exception has been thrown or caught. It tests only what happens here. Did we expect a 201 created status on the response and it happened? Yes, the test passes. No, the test fails. Did we get back the information that we expected from the database? Yes or no, and so on, without putting too much stress on how that happens behind the scenes. This integration test here tests the integration with your application from outside. It tests the contract, and in case of REST endpoints, it's one of the most valuables because it's basically acting like the client. We, for example, do very often this using Mock MVC. Mock MVC is an excellent tool that is very easy to use. It's basically a dependency you add, and when you run the test itself, it starts the application, the container. It runs the requests over the endpoints, and it validates that what happens is correct. And in this case, this is excellent because again it doesn't force you to have a specific design. So then when you change something here, you can change it without changing the test at all. So that's why in this case you don't need necessarily to have a good structure of the code before writing the test, because here with this kind of test you focus on the contract, so what goes in the application and what gets out, but not on the logic. But unit tests, they do focus on the logic. So that's why I usually recommend focusing more on the contracts where possible through integration tests and not necessarily on the fixed logic. And then when you, as you say, have a good code structure and you know is the final one, then make it solid with unit tests. And this is what is this? Testing strategy. We go back to exactly what I was emphasizing at the beginning of this video. What I'm creating now is a testing strategy. This is what, in my experience, is missing a lot in applications and systems. Developers simply write tests to make coverage, but they don't have a logic in which they decide how and what tests should they write depending on what exactly their system is and how. So this is an example of how should you think about when designing your tests and creating a testing strategy that you follow before. Now it's exactly like when you decide on some ways of writing the code, on some way of writing the design, whether I use a linear design or a hexagonal, whether I use microservices or monolith, whether I use the same thing, you have to decide for testing. And then of course, in the same way, a designer, a developer, an architect decides for the code, how it looks like depending on compromises of benefits and of course pitfalls. The same, we decide what kind of tests we write depending on the benefits we gain and pitfalls, getting for us the best compromise, no, because it's always about the compromise. Remember, in software there is no silver bullet, no. So I'm a newbie to Spring Boot, but how would you say one should start learning testing or approach it in a particular project for learning? Very good question. I don't have an answer for you because I didn't apply this, but I was saying at the beginning of this video, actually the next playlist I'm creating will be on testing, and I promise you that in that playlist I'm gonna go in details with how we create the testing strategies. Of course, we will go through types of tests and then discuss on testing strategy and everything that you need to know as a developer. No, I'm not going to go into QA side. I'm going to go straight into development, but you will see that again, testing is a very complex, much more complex and underappreciated subject. So going back now, we focus on testing the integration. This is one of the tests. Now we test, as I've said, we test the integration through contract of the logic in the application with what the client expects. What else we test? We write Spring integration tests to test the integration of your application with the Spring framework. That's why they are called Spring integration tests. No, why? Because you want to test, I was saying also earlier a bit, how your application uses capabilities Spring provides, like transactionability, aspects, Spring security, the annotations. You've maybe used a pre-authorize or post-authorize, or you've implemented some, I don't know, different authorization rules. You want to test that they are applied correctly, and whenever someone changes something, if the logic behind the authorization rules is changed, then they have to be made aware by the test failing. Or if they go from Spring Boot 3 to Spring Boot 4 and something changed, maybe something is not working anymore the same, if you have the integration tests with Spring, they will flag anything that might have changed. So they make you aware of something that has changed in logic before you end up with some implementation sent to production and then not working properly. Yeah, I promise I will do my best to stream more often, so I'm happy that you are asking that, actually. And there were a lot of gaps because of my timetable lately, but I promise I will do my best. So how good it will be to have the entire subject of software testing as a playlist? Yeah, we will do that. Yeah, we will do that, exactly. And the same as all this will be live, so that you can join here, but they will also stay recorded forever on the channel, so anyone can see them afterwards, or later if they cannot attend and ask the questions in the comment section. And then, no, I was discussing about two of them. I've told you about two kinds of integration tests. So we have the integration test that is the contract, the one that tests the framework, the Spring integration test, how we call it. And then we have the third one, which usually means integration with some external component that our application calls. This can be another service through a proxy usually, or it can be the database through a repository. But remember, we were discussing that in a way or another, a repository is still a proxy. It's actually the same kind of object. It's a proxy to a database, if you want. Because what was the definition of a proxy? It's that object that implements the communication with something else. Usually, if that something else is a database, then we call it a repository. So when we have this kind of test, if it's a proxy and it's communication with another service, it basically looks like the contract one, but it's the other way around, because here our application will actually be the client, and here what we can use is a WireMock server, for example. It's very often implemented. So if for the client we use mock MVC, for the proxy we use WireMock server. WireMock server creates a stub. So it creates basically a mock server that you call and that you tell how to behave, same as you were doing with the mock objects in the unit tests that we discussed in the previous video. So you are able basically to, considering that the external server behaves in a certain way, you prove that your application behaves correctly according to how the external dependency is behaving. And then you can test your retry mechanism, you can test your circuit breaker, you can test that the request is translated correctly when it's a success, but it's also translated correctly when it's a failure, whatever is part of the logic. And then of course you can integrate this. I'm gonna end with that, integrating with the logic now. You can test also the integration with the logic of this. You can test that your logic here behaves correctly according to how your repository or proxy behaves. And then for the account repo, if it's a repository here, because it's a database, we have different ways to test the integration with the database. What happens in a lot of cases, it's either one, it's completely skipped. I've seen this a lot, and sometimes maybe actually in a lot of cases it might make sense. You mock the account repository and you can test basically the logic in the service simply by mocking the account repository, this way completely skipping over testing of the integration with your database. You always have, and this is part of the testing strategy you apply, you always have to ask yourself, does it make sense for me to test the integration with the database? How much benefit it brings me, and how it compares to the pitfall that I get, which is usually time spent a lot for designing the tests. That time invested will bring me a good return of investment, and this of course depends on the system, on the sensitivity of the system of the subjects that we discuss. More messages from you guys. So, like a message broker. Message broker, it's actually a message broker. Okay, it's part of the earlier message. A message broker is actually a very good point. It's actually a different subject, but in the most cases when we talk about the testing of a message broker, of the integration with a message broker, we discuss about either testing that the messages go through to a different cure topic, and then what happens when they get consumed. So that's basically what we do, but I will skip over this in this session because it's again a bit too far away from our subject. No, but I will discuss it, for example, in a playlist dedicated to that. Is this the last episode? No, yes, this is the last episode of this playlist, and then the next playlist, I promise that I will go deeper into testing. Okay, I will start a new playlist on testing. Good. Yeah, and I saw the test containers. Good catch there, very good catch. The last message, test containers. No, I was actually discussing this now, and I said, do you have a few options? No, one option is to completely skip over testing the database. A second option is using an in-memory database such as H2. For example, in case of Spring Boot application, you will very often see H2 or similar database, similar technology being used as an in-memory database. I normally do not recommend that, and I will explain. When you implement an application, let's say it's a relational database for simplicity, no? Because we discussed about H2 in case of relational databases. You will have a Postgres, a MySQL, an Oracle, an MS SQL. You will have a technology. They differ, and they differ to H2 as well. So you will have situations where H2 will not be able to behave the same as Oracle or as Postgres and so on. So you will not be able to design fully 100% tests that are correct. It's a very simple approach to use an H2, but usually starting and creating that H2 database plus testing on it and having the non-benefit of not being able to always have the same, let's say, syntax and so on, and forced. Sometimes I've seen developers being forced and doing adaptations for H2, which is like, man, it's wrong. You don't adapt your code for the test. You need to adapt your test for the code. So the purpose is you test your code, not you create a code for your test. Okay, so never do that. Whenever you find in a situation, and regardless of the case, whenever you find yourself in a situation where you have to adapt your code for the test, something is wrong. You never adapt the code for the test. The code is the code. It reflects the implementation and that you need to test, and then you write the test for that implementation. You don't have to adapt your code to make the test work. And then we have the possibility to use the real database in an environment. Now I've seen that as well. The developers say, okay, I cannot use H2 because I want to test with exactly my technology, Postgres. Very good choice. It's anyway better than using a different technology for the test. And in that case, you have two options. One is having a real test database in a test environment. I have seen that in many cases, and it works. But it has a problem as well. Even if it's better than H2, the problem is that being not in memory anymore solves a problem, gets another one, which is the network, which is not 100% reliable. And it will happen from time to time that in a pipeline, in a CI/CD pipeline, for example, which I presume you have for your services, for your applications, the tests will sometimes fail just because there was a network issue somewhere, there was a firewall somewhere not behaving correctly, something happened, and it's not a test problem, and then you have to rerun the pipeline, and the pipeline takes a lot of time, and it has to, the calls are taking longer themselves because they have to connect through the network, sometimes having some security in place, and this is frustrating and consumes a lot of time. It works, it's better than having a different technology for the database, but it's not the best. And now if you are asking me which would be the best, actually, is what that our friend here said, which is called test containers. Test containers is an excellent technology, and I recommend you have to, from my point of view, two decisions to take. You either test your repository or you don't test your repository. If you don't test your repository, that's fine. If it makes sense for your testing strategy not to test the repository, that's fine. If you want to test the database integration as well, then use test containers. It spins, it's like an in-memory database because it creates the database for you, but instead of creating it in memory, it creates you in a container near your application, and using the exact, you can use the exact technology that you need. If you have a specific Postgres version, you can use that specific version, and then you know that you are testing with exactly the technology your application uses, which gives you basically all the good stuff from all the approaches. So that's why I always recommend test containers when you go into testing your repository as well. Okay, so that's basically it. Now let's go very quickly through the difference between how a Spring integration looks like. I'm not going to discuss here about WireMock. I'm not going to discuss about mock MVC. I'm not going to discuss about test containers. No, they are way beyond the scope of this book. And in this particular playlist, we still are around the Spring Start Here book, which gives you the good career path for learning, the good path for learning Spring framework from the very beginning, from zero. That's why Spring Start Here. No, here is the first edition. now, first edition, and this is also a good time to tell you again that we will soon start a new edition for the book, and the book is basically, the first edition is printed in multiple languages. So you have here an example of the Korean translation of Spring Start here. It was a very appreciated book actually, and I hope that the second edition will be also. Going back now, look at this. So remember how this actually looked like, this test. See, I was using here an extend with Mockito to be able to create mocks, but this annotation basically can actually even be missing, assuming that we would not have mocks. It rarely happens, but I want you to understand that is for the mocks and not for the test itself. Okay, and then that's it. Then everything happens inside. You create the mocks, you have the alternative to use the method, or you use the mock annotation, mock inject mocks. They create objects and that's it. So these annotations, they have nothing to do with Spring. They are simple JUnit and Mockito technology to allow you create some objects easier. If we go to the integration test to compare, here you have first of all this at Spring Boot test annotation that appeared. This is very important. This makes it a Spring integration test. Once you have this annotation, then what happens is that the Spring context will be created when the test starts. So you automatically now introduce Spring in the equation. Up above, there is no Spring happening. If you run this test here, there will be no Spring happening. The context will not be opened. You will be able to see that in the logs. It simply tests the logic and that's it, because it's a unit test. But when we talk about the Spring integration test, it's called the Spring integration test for a reason. It tests the integration with Spring. So it has to what? It has to create a Spring context. Because the Spring context is the heart of Spring. That's why we've discussed it in a full part 1 of the book. It's what gives Spring purpose. It's how Spring controls instances in your application. And then you have another annotation that you will recognize here, which is the auto-wired annotation, which is the real injection annotation that we use with Spring, which we discussed again in part 1. So here we can prove that we don't only create a test service, but we work with this test service where? Inside the Spring context. So this will happen inside the Spring context. And then we have the repository is no longer only mock used. This is mock bin. It has been replaced in the latest version with a different name, which is called now Mockito bin. Okay. I won't comment about why this was changed, but it's the same thing. It's just a name change. So in the newer versions of Spring Boot, you will find the name of Mockito bin, not mock bin. It does the same thing. It creates a mock, but this mock is not like this mock here. This mock here is just an object, while this one here is not just an object. It is also added in that Spring context created by the test, because we have added Spring Boot test above the class, which makes these two objects here not only simple objects as it happened in the early discussed unit test, but an integration test, at least with the Spring context. Now, because we integrate with the Spring context, you can now test not only the fact that the Spring context works correctly, but also whatever else you are using. Like, for example, you can test the transactionability. You can test that the transactional on your method works correctly, that the transaction rolls back when you throw a runtime exception, which we know is the way it should behave now, as we discussed in one of the earlier chapters. You can test that pre-authorize applies correctly your authorization rule. You can test that a given aspect is run. You can test whatever Spring provides you and you want to test. That's why we write Spring integration tests. And that's how they differ. And that's why we have different annotations. No? So that's basically what you need to know. I'm gonna stop here because this is basically what we wanted to discuss related to the book, and I want to still hang only around this book in this playlist, which ends here with this video. But again, as I've told you, other videos will come and we will discuss much more about all these subjects. Already some of them are there, some of them are maybe outdated and I will have to recreate them, but the majority of them are still good enough, so they should help you learn better different Java stuff, as I'm always trying to do on this channel, and I will try to do it more frequently. Before I completely end with this playlist, I want just a very short recap on what we've done and what I recommend you, which are my recommendations for you about Spring and learning Spring. First of all, a very big question. People asked me, does it make sense to learn Spring anymore since now AI is doing everything? The answer is yes, because AI, at least the way it is now, it doesn't necessarily write the correct code, even if it's working. Don't use it like, again, it's the difference between being a driver of a car versus the mechanic of the car. The mechanic knows much more than just driving the car. It knows how the car works, how the engine works. It's able to correct it and to adjust it, to fix it when it's needed. This is what you need to do. And in order to do that, you need to understand, it's like now, even now, before AI, we did still have to understand the basics of how a system works, even if you don't, like, for example, use assembly anymore and CPU registries, you are still taught about them and learning how that works, because you need to know how everything works behind the scenes. So if you want to be a Java developer, and today a Java developer somehow it means with Spring, then you need to learn Spring and don't only rely on AI technologies, okay? And then what you should do, and why this book was designed the way it is part 1 teaches you the very super basics, not with Spring Boot, but directly with Spring Framework. With that very core that teaches you what beans are, how you link beans among them, how you use abstractions, and how is that possible, how the beans live, which is basically part of what we call dependency injection. And then chapter 6, aspect-oriented programming, which is basically the other part of what we call inversion of control. This part 1 is not only useful for you for Spring, but if you understand it, you will understand all the frameworks, and not only in Java as a technology, because you will understand fully the concept of inversion of control, which is extremely useful. And then part 2, the implementation, or using Spring in implementation, is teaching you with Spring Boot, because yes, when implementing stuff today, you rarely use directly Spring, only maybe in older applications. So that's why my decision was to start the implementation part with Spring Boot, but only after I taught you the very basics here. And now we discuss about how Spring MVC works and how you write web applications, how you write REST services, how you connect with data sources and use transactions, and of course at the very end how you test your application. This is the very foundation any Spring developer should start with. Once you know these things in detail, once you are comfortable and there are no question marks about any of this, then you will be able to step forward and understand any module in Spring. You will be able to take further and understand better Spring Security, Spring Cloud, Spring AI. All the modules rely on part 1 here. And then of course you need to know the very basics of building the simplest of the applications. And this is what the Spring Start here brings you. And I will enhance the Spring Start here with a second edition that will teach you how to do this with Spring Boot 4 and Spring Framework 7 and above. And of course, the newest stuff that appeared throughout the time. I'm very happy again that you have been here with me, friends. So I've seen your messages and they always warm my soul and my heart to see you here with me. Like always, dozens of people follow this video streams live, and I will again try to make them as often as possible. I'm gonna stop here with this lesson and with this playlist, of course, but it's just an end of a playlist. There are new ones to begin soon, so see you next time, and until then, have an excellent time for learning. Cheers.